Welcome to 𝐏𝐿𝐴 Once and Only Mathematics Group. We are a combined group consisting the classes of secondary 2 and 3. My name is 𝐿𝐴 or I can be called Izzy in this interview. Our group members are Lily, Avery, Lila, Scarlett, and Ronald, Robert, Brian, William, Nick, Neil, Luke, and me. So I'll be the reporter for this interview. So can you guys please introduce yourself?
Of course. Hello friends, my name is Lily and you can call me Lily in this interview. So my job here is to be an engineer focused on the algebra topic in this project.
Hi everyone, as for me, I have occupation of being an engineer for this mainly focus geometry for the design of the building. My name is Yala, but I'm here as Lila for this interview.
Okay, so let's start the whole thing real quick. So I'm already so curious about how you guys build this amazing creation as a team together, and I'm also curious about how these things works in real life. And I will even doubt that is it even possible to build one like this in real life? That this is so amazing.
We'll prove you wrong. Okay, so let's start with this Yangon School Campus 1 building. So we use cardboard, color paper, and paints to create this model construction. And we're going to use this in real life. So we're going to use the dimensions, which are the width, height, and length. So we're going to use those dimensions to calculate the estimated budget of the real life construction. And also, we're going to use this building in civil engineering. You know how? We're going to use the dimensions and we're going to put them in the mathematically similar format, which we learned in our lessons too. So this is both useful for students and engineers. So for this solar thing, we're going to use it for the gradient, the slope, and which is not a straight line. So we're going to use that for balancing the solar on this building.
Okay, so how about the structure behind it? I think geometry has something to do with it.
Okay, let me explain about it. This is a pentagon and spiral shape with it, and we construct with those kind of each polygons, the pentagon shaded. And first, we want to tell you guys that how important the interior angles and exterior angles are. This is first before we structure this thing, we have to know about the interior angles and exterior angle deep. And for you guys, for the audience, we make this kind of formula spring wheel. This is the interior angle for each polygons, and this is for the exterior angle. And this is how we build it as a 3D shape.
Okay, so how is this small little thing works? Can one of you explain?
Sure, of course, I'll explain. So we use mainly algebra for this little hut building. You guys may have seen this in our country too. So there's those little huts where security sleep in townships. So this is their little working space or sleeping hut. So we use the x and y, which are the unknowns, to know the perimeter area and volume equations. So we're gonna put those measurements into the equations and we get the measurements for the real life measurements. So we're gonna put them in the mathematically similar format again to get it. And we're gonna build it in real life like that. So what about this little swing? Would you like to explain it to Izzy?
Okay, fine. And this is the small structure of the stream. This is we use the area, the shade of the pentagon for the base to sit people. And this is we use the trigonometric ratio to balance the how can I say it? To balance the spring, yeah.
Okay, I see. That's amazing. So how about this game? It looks so interesting.
Thank you. So we're gonna, these are the answers on these little boxes. And if we remove these boxes, we see the questions. So basically you have to match these questions to each question. And if you get it all right, then you'll get a prize, which is a bracelet made of wool. So we have many of these because you'll only get it if you win this game. But if you win the game with our questions too, the other questions, so 2 games basically, then you'll get also the another type of bracelet, which is made of charms. So Lila, could you please explain about the Ferris wheel again?
Okay, this is the things what we make together as a team for the audience. These are the formula that we have to learn in the high school, and also it's really useful for the university student. All of the formulas, we want to give the message for the audience that the things that we are learning in the high school are not just a lesson, but we can also use in real life, such as mathematically similar to build a real construction and building not as a model, but also the real things.
Wow, the whole thing is just so impressive. Okay, so I'll just summarize everything they just have explained to me. So very first of all, we're gonna have to get the model measurements and we're gonna put it in a fixable algebraic equations. Next, we're going to check for the sizes, angles and vertices and everything, also the shapes. And we're going to put all of them together in a mathematically similar equations or format to finish it all off. So, and by doing all of that, it could give us the accuracy when we build one like this in real life. So that is why, welcome to the maths world. See you soon.